All right, for the first question, if sine theta is greater than 0, then that means the y-coordinate must be greater than 0, right? So we have y greater than 0. If cosine is less than 0, that's x is negative. And so that tells us that it's in quadrant 2. Okay, quadrant 2 is the only quadrant that has negative x values and positive y values. Questions? Moving on. If cosecant is negative, that means sine must be negative, right? Because cosecant is the reciprocal of sine. So that tells us y is negative. And if secant is negative, that tells us cosine is negative, so x is negative. And that puts us in quadrant 3. All right. Who has parts C and D?
C is quadrant 3,
3, 2?
Quadrant 3.
Yes, that's right. C is quadrant 3. How about part D? You ready? Quadrant
2.
Part D. It's quadrant 2. That's correct. Very good. All right, part C, tangent. If tangent is positive, then that means that y over x is greater than 0, right? So that means they have to either both be positive or both be negative. But we know also that y is negative because sine of theta is negative. So that tells us that x is also negative, which places us in quadrant 3. Tres, right? In Spanish, uno, dos, tres, cuatros. That's about all I know. Okay, now if cotangent is negative, then that means that x over y is negative, which tells us that x and y have opposite signs. So either either one is positive and the other is negative, or vice versa. But we also know that x is negative based on cosine theta being negative, so that tells us that y is positive. That places us in, I'm blanking out, quadrant 2. Okay. Okay, any questions? All right, next set of questions. So today we're just going over the 3 questions that will appear on the quiz on Tuesday. Second kind of question is finding 2 values of theta, right? We already saw that last class, but we just want to review it a little bit. Find 2 values of theta, where theta is greater than or equal to 0, but also less than 2 pi. Let's do first sine theta equals negative root 3 over 2. Okay, so find 2 values of theta such that sine theta is equal to negative root 3 over 2. Okay, what's the main idea here? What's the first step, guys? We're really just looking for 2 points. We're looking for 2 points on the unit circle that have y-coordinate of negative root 3 over 2. Anybody know what negative root 3 over 2 is? Negative 0.866, right? So that's around right here. And I'm drawing a line because everything along this line has the same y-coordinate. They all have y-coordinate of negative root 3 over 2. So essentially I'm looking for the 2 points where this line intersects the circle. That'll tell me which points on the circle have y-coordinate negative root 3 over 2. And that's these 2 points, which are 4 pi over 3 and 5 pi over 3. Okay, I got those because basically we're just starting at pi and then going 60 degrees counterclockwise. Or for the second one, I'm starting at 2 pi and then going pi over 3 backwards. Got it? So that's how I get at 4 pi over 3 and 5 pi over 3. Okay, if you don't know why it's 60 degrees, you can always draw a triangle like this. The radius is 1 here. And if this is, if you know that this length is root 3 over 2, then you know that this degree is 60 degrees. So that's how you can know it's a 60-degree angle there. Questions? All right, you guys can do one by yourself. Find two values of theta such that cosine theta equals, what did I do for my 1a? Negative root 2 over 2. So cosine theta equals negative root 2 over 2. So now we're finding 2 points with x coordinate, negative root 2 over 2, right? Negative root 2 over 2. Okay, so draw your unit circle, then draw maybe a vertical line this time at negative root 2 over 2. Because all those points on that line will be negative root 2 over 2. X coordinate. Where to put the dot? The line. You put it at x equals negative root 2 over 2. Because if cosine theta equals negative root 2 over 2, then that tells you that the x coordinate on my unit circle must be negative root 2 over 2.
Wait, so do I like guess?
Huh?
Do I like guess, kind of like, you know what I mean?
What do you mean guess?
Like,
Okay, so I'll draw my circle here. And I'm looking for basically all the points on the unit circle with x coordinate negative root 2 over 2. That's right here. Okay, so that's these 2 points. It might help you to know these values. 1/2 is 0.5. Root 2 over 2. Anybody want to guess? Anybody want to guess what root 2 over 2 is?
7.66.
Somebody get 2 digits.
What?
725.
7.3.
7. So wait.
7.6.
or is it
Yeah,
8-7?
7-1. 7-1.
I was. Oh.
And root 3 over 2 we all know, right?
0.8. 0.83.
No.
Oh. 0.866.
Let me put my high tree back into my bag. Everybody failed. All right. So these 2 points are 3 pi over 4 and 5 pi over 4. Okay? Because we know that this is pi and we're going pi over 4 backwards and forwards, right? If you didn't know where to draw the line, then you could always draw this triangle and you would know that because this is 1 and this length has to be root 2 over 2, then this angle must be 45 degrees. So that's another way of drawing it out, actually. Questions? Next. Tangent is really harder, so I want to go over it a lot more. Really harder, yep. So let's say we're looking for 2 values of theta such that tangent theta equals 1. Okay? Now, tangent is harder because it doesn't actually correspond to a coordinate on the unit circle. We have to kind of infer what x and y are. Okay? What? No. Nope.
So, root 2 over 2 and root 2 over 2.
Sine over cosine.
Okay, tangent can only equal 1 when sine and cosine are equal to each other. And we can kind of infer, based on our knowledge of the unit circle, that sine and cosine are only ever equal to each other when they're both equal to plus or minus root 2 over 2. Okay? So either they're both positive root 2 over 2, or they're both negative root 2 over 2. And if we go to those points on our unit circle, no.
Pi over 4.
gosh.
Pi
Yes.
over 4. Pi over 4, pi over 4.
Pi over 4. And 7 pi over 4.
Yeah, sorry, Sophie. Wrong answers just keep coming out of your mouth.
Oh, I got it wrong. Oh, I
Right? Because this is root 2 over 2, comma root 2 over 2. And also this point is negative root 2 over 2 and negative root 2 over 2. So that's pi over 4 and 5 pi over 4. Okay? So that's kind of one way of doing it. I'll show you guys the way I actually do it in my head. I don't do this.
No, we get it. It's one of those.
No, I'm trying to teach you the clever way. Slick way. Okay, are we all good with the slide? Okay, my trick is that tangent corresponds to the slope of the line. Let me explain what I mean. Tangent theta equals sine over cosine, right? But this is also equal to y over x, right? And y over x is just the slope. So if tangent theta equals 1, then that means the point on the unit circle when connected with the origin must have a slope of 1. Okay? So I'm going to draw a line of slope 1 that goes through the origin for my unit circle. I'm going to draw a line of slope 1. And the points I'm looking for are simply where it intersects the unit circle. And I'm done. Pi over 4 and 5 pi over 4. Okay?
So I have so much easier.
Well, it's it's a trick. So both ways are okay on the quiz.
That doesn't have a it's like a shortcut.
It's how real people do it in their heads. But you need to learn this way first, of just knowing the unit circle. Okay? Let's do another. We need to do pretty much all the tangents just so we're all clear with them. Let's say that tangent theta equals root 3. Okay? Well, the only possible values of sine and cosine that give this ratio are going to be root 3 over 2 and 1/2. And you kind of just have to know that. Okay? We know that the root 3 has to be on the top because this is equal to root 3, right? If it were 1 over root 3, it would be on the bottom. Okay? So that's one solution, and we also have to include the other negative solution, right? Negative root 3 over 2 over negative 1/2. So that corresponds to the coordinates, right? Cosine must comes first because it's x. 1/2 comma root 3 over 2. Girls, stop talking. Girls. No, they're loud. Otherwise, I will separate you. Oh, okay. Oh, sorry, there's a negative here, right? Okay, so we're looking for these 2 points on the unit circle. And that's right here, right? Because 1/2 is around 0.5, and root 3 over 2 is about 0.87. Root 3 over 2, 0.87. Okay, and then the other point is right here. So that puts us at pi over 3 and 4 pi over 3. Okay? If you were confused about how I arrived at those points, you could have also drawn the triangle, although I just visualized it in my head. So that's 1, and then because I know the x-coordinate has to be 1/2, this length is 1/2, which makes this angle 60 degrees. So that's how you can get pi over 3, writing it out.
Wait, can you use like the slope thing?
Yes, you can. That's how I do it.
Is this rise over 1, right?
Yes. Okay, are we all good with this picture? Okay. Well, the slope trick, if tangent is equal to root 3, then that means the slope has to equal root 3. And root 3 we all know is 1.73. Okay, and that's bigger than 1, yes. So we know it has to be a steeper line, right? So the line has to be steeper than 1. And so that means we can pretty quickly see visually that it has to be like this, which gives us these 2 points. Okay? Are we all good with the slide? On the other hand, if we had tangent equals root 3 over 3, what is root 3 over 3? Anybody?
0.567.
Good. 0.58 slope. And that's shallower than 1, right? So we would draw the line like this instead, which would give us pi over 6 and 7 pi over 6. Okay. A lot of sound effects today, Sophie. I don't know why. You're making many sound effects today. I don't know how I feel about that. Okay. I'll also show you guys how to get that from maybe the coordinates, right? Because that's important too. So if we had tangent theta equals root 3 over 3, first we would rewrite this as 1 over root 3. That's probably the easiest way to see it. And that tells us that sine over cosine is 1/2 over root 3 over 2. Right? Because this time the root 3 has to be on the bottom. So that's how we would get that. Okay. All right, I'll let you guys do one by yourself. Cotangent theta equals negative root 3, please. Find two values of theta. You can do either method.
What is the extra credit thing that people are saying that they're able to do? I didn't.
It's like due today.
Oh.
Do you actually want to do it?
Yeah.
Yeah, we can talk after class then.
Okay, thank you.
Wait, can I do it?
Also after class.
Okay, who has the answer? A good first step would probably be to change to tangent. Right? Makes it a little easier since we've been looking at tangents mostly.
Can I guess?
Okay,
5 pi over 6 and 11 pi over 6.
very good. You can get a high chew.
Oh, thank you.
Good improvement, Sophie. Some correct answers this time. Okay. Cotangent theta. I'll do it the first way, okay? Cotangent is equal to cosine over sine. So in order for cosine over sine to equal negative root 3, there are only two possibilities. One is that cosine is negative root 3 over 2, and sine is positive 1/2. Or we have positive root 3 over 2 over negative 1/2. Okay, so in terms of coordinates, that's negative root 3 over 2, comma 1/2, or positive root 3 over 2, comma negative 1/2. And so on the unit circle, we would be able to find this point and this point. So that's 5 pi over 6 and 11 pi over 6. Okay. Well, I did a few steps in my head. But basically you can draw this triangle, and you know that this height has to be 1/2 because that's the y-coordinate. This has to be 1. So this is 30. And so basically I'm starting at pi and going 30 degrees backwards. So that's pi minus pi over 6, 5 pi over 6. Okay, same for the 11 pi over 6. That's 2 pi minus 30 degrees, pi over 6, so 11 pi over 6. Okay, and then if you wanted to do my trick, you would first write tangent theta equals negative root 3 over 3, right? Which is less than negative 1. Or sorry, more than negative 1, but in magnitude it's less. So it's shallower in terms of its slope. So then you would draw your unit circle, and then the line would look like this. Because the slope is negative 0.58, right? So you get the same 2 points. That's a trick that I like. Next quiz is 30 points, so refer to questions 4, 5, and 6 on the practice quiz. But because it's 30 points, questions 5 and 6 will be doubled. Make sense? Meaning that instead of 2 parts on each question, there will be 4 parts. just repeating itself with different numbers. I just wanted to make it more points, just for fun. And we'll say 20 minutes for the whole thing.
Why 20?
It's a little shorter, I guess. Same amount of points, but takes less time than the unit circle stuff, which is pretty tedious. Okay, any questions about finding sine, cosine, tangent, cotangent? Okay, you might see a question involving like secant, cosecant. That's pretty easy, right? You just change it to cosine. That's it. Okay, what was the next thing I want to go over? Oh, it was question 4 on the test. Okay, that's the kinds of question where I give you sine theta. So like if sine theta equals 3/5 and theta is in quadrant 1, then find ... This actually might be identical to one of the versions. Oops. All right, so you have a 25% chance of seeing this on the quiz, I guess. If you can memorize it, which I doubt you can. So you actually have to know it anyways. Okay. Oh, wait, the quiz has alpha, not theta. Oh, it's a letter?
Is it the same? Is it just like variable?
Yeah, it's just change the variable name. People don't use x or y for degrees. It's a bad convention. Okay. Degree measures, or sorry, angles are always Greek letters, right? As a convention. So you'll see alpha, beta, gamma, delta. No epsilons. No deltas either. But theta. No pi, right? Of course, because you can't use that as a variable.
Wait, those are all the same, like just different variables?
Yeah, they're different letters, essentially. All right, alpha, beta, gamma, delta, epsilon, zeta, eta, theta. You guys know zeta?
Is that Z?
It's a zeta, eta, mu.
Is it like hieroglyphics?
They're not like hieroglyphics at all, actually. Okay, part A, find cosine alpha. Part B, find sine of alpha plus pi. Part C, find sine of negative alpha. Part D, find sine of alpha plus 2 pi. Part E, find... What else did I put on there? I'm blanking. What did I put on the test? Weren't there 5 parts?
It's sine,
Cosine, negative?
yeah, cosine
Negative
pi over
cosine?
2 minus a.
Oh, yes, you're right. Cosine pi over 2 minus alpha. And then part F is not on the test, but it's not on the quiz, but it's on the practice quiz. So you might still need to know it.
They don't have a pi.
Part F is sine of pi minus alpha. That one's tricky, so I didn't put it on the quiz. All right, who has the answers?
2.
4 answers, not good enough.
So like, it's like a normal triangle.
I'll give you hints for each one. Part A, you need to use the fact that our Pythagorean identity, right? Cosine squared equals 1 minus sine squared.
Isn't it just 4 over 5?
Yes.
Why do you do all that?
Huh?
Why don't you like...
Okay, let's just go over it. Part A. Cosine squared is 1 minus sine squared, right? Because of the Pythagorean identity. So that means cosine squared is 16 over 25, which you can check at home. Which tells us that cosine alpha is equal to plus or minus 4 over 5. Okay? But we're only going to choose the positive value because alpha is in quadrant 1, which tells us that cosine must be positive. The answer is 4/5. Second question, sine of alpha plus pi. Here, we're going to use logic that we get from the unit circle. Okay? The idea is that if alpha is here, if alpha is here, then alpha plus pi is right here. Right? So that's going to flip our y-coordinate. It's essentially a reflection across the origin. So the y-coordinate is going to flip, which means that sine of alpha plus pi is negative sine of alpha, or negative 3/5. What? What? Wait, I didn't mean to write negative. Meant to write alpha plus pi. Okay, so x and y both flip. Okay, good. So that tells us that cosine also flips, right? So if your question was cosine alpha plus pi, then that's equal to negative cosine of alpha as well. Okay. Next one, part C. Here you can simply use the fact that sine is an odd function, so this is equal to negative sine of alpha. You can also see this from the unit circle, right? Because if alpha is here, then negative alpha must be here, right? And that flips our y-coordinate, or it flips our sine. So that means sine becomes a negative 3/5. Questions up to here? Okay, sine of alpha plus 2 pi. Whenever we add a multiple of 2 pi to the argument, that doesn't change the value of sine, right? So this is equal to sine of alpha. You can also see this from the unit circle very easily. If sine is here, or if alpha is here, then alpha plus 2 pi is also at the same point, right? So that doesn't change sine at all. So sine of alpha is 3/5. Ginger?
So if the point is in B, sorry, I know this is late, but if the point is in B and it goes from quadrant 1 to quadrant 3, doesn't that mean that technically in quadrant 3 both parts are negative, so it's positive?
For part B?
Yeah.
Yeah, both x and y will become negative.
So that means, doesn't that make them a double negative, which makes it positive?
But we're looking just for the y-coordinate, right? We're only caring about sine of alpha plus pi, which is the y-coordinate. So that's just negative. Tangent, on the other hand, would be positive, yeah. All right, cosine pi over 2 minus alpha. That's harder to visualize graphically. So here we really just use our cofunction formula. Cosine pi over 2 minus alpha is equal to sine of alpha. Right? As you guys remember, cofunctions of complementary angles, so pi over 2 minus alpha, are equal to each other. So that's 3/5. Okay, that's from the first lecture. Sine of pi minus alpha, that one's tricky. I went home and asked ChatGPT the best way to explain this, and they gave me a very helpful tip. So basically, pi minus alpha is a reflection across the y-axis. And here's a way to see that visually. Okay? Let's say that this point is alpha, okay? Well, in order for this point to be alpha, then we're basically starting at 0 and going counterclockwise alpha, right? Well, what's pi minus alpha? Well, that's none other than starting at pi and then going alpha backwards. So that places us at that point. And that's simply just an inversion across the y-axis, right? Therefore, that keeps our y-coordinate the same. So sine of pi minus alpha is equal to sine of alpha. Okay? On the other hand, the x-coordinate flips, right? Because it's a reflection across the y-axis. So cosine of pi minus alpha would be equal to negative cosine of alpha. Okay, so that's how you do these things with unit circle logic. Okay? These quizzes are very easy to study for if you work hard, as you guys have been able to see. What? We have about 5 minutes left.